Here we'll find a formula for the sum of the angles in different polygons. For example, here's an octagon, meaning it's a polygon with 8 sides. Let's label all the angles in this polygon. What do these angles add up to? To find out, let's start with a simpler polygon, like a triangle, which is a polygon that has 3 sides. What's the sum of the angles in a triangle? If you're not sure, click down here. Exactly. The angles in every triangle always add up to 180 degrees. Next, let's look at quadrilaterals, which are polygons that have 4 sides. Here are a few examples of quadrilaterals. Let's take a closer look at the rectangle over here. Rectangles are quadrilaterals whose angles are all right angles, meaning they all equal 90 degrees. What's the sum of the angles in a rectangle? So because every rectangle has 4 90-degree angles, the angles in a rectangle always add up to 360 degrees. Now, with this interactive graph, you can make any quadrilateral you want by dragging around these 4 corners. The quadrilateral's 4 angles are also shown up here, and for this quadrilateral, they add up to a complete rotation. In other words, the 4 angles in this quadrilateral add up to 360 degrees. Try making a quadrilateral whose angles add up to something other than 360 degrees. So it seems like the angles in every quadrilateral always add up to 360 degrees. So these angles over here add up to 360, these angles add up to 360, and these angles also add up to 360. One way to show this is true is to divide each of these quadrilaterals into 2 triangles. So this quadrilateral can be divided into 2 triangles like this one can be divided into 2 triangles like this, and the rectangle can also be divided into 2 triangles. Every quadrilateral can be divided up into 2 triangles, and as you know, the angles in each triangle add up to 180 degrees. Therefore, the angles in every quadrilateral must add up to how many degrees again? Right. The angles in every quadrilateral add up to 360 degrees because every quadrilateral can be divided into 2 triangles. Next, let's look at pentagons, which are polygons with 5 sides. Every pentagon can be divided up into the same number of triangles. What is that number? When you're dividing up the pentagons, just make sure the triangles don't overlap, and feel free to ask for a hint if you need it. Exactly. Every pentagon can be divided up into 3 triangles. For each of these pentagons, there are a few different ways to divide them up. But here's one way for this pentagon, here's a way to divide this pentagon, and here's a way to divide this pentagon. So if every pentagon can be divided up into 3 triangles, and the angles in each triangle add up to 180 degrees, what must the angles in every pentagon add up to? Precisely. The angles in every pentagon add up to 540 degrees. Let's see if we can find a pattern. Let's look at polygons that have 3, 4, 5, or 6 sides, and here are the names for these polygons. Let's write down how many triangles you can divide each polygon into. A triangle is already made up of nothing but triangles, so let's say we can divide it up into 1 triangle. You found that every quadrilateral can be divided up into 2 triangles, and that every pentagon can be divided up into 3 triangles. It turns out that every hexagon can be divided into 4 triangles. Do you notice a pattern between the number of sides in a polygon and the number of triangles you can divide it into? Now suppose you have a polygon with n sides, which is also known as an N-gon. In terms of n, how many triangles can every N-gon be divided into? Right. Every N-gon can be divided up into n-2 triangles. Now let's look at the sum of the angles inside these polygons. The angles in every triangle add up to 180 degrees. The angles of every quadrilateral add up to 360 degrees, and the angles of every pentagon add up to 540 degrees. Since every hexagon can be divided up into 4 triangles, and each triangle has 180 degrees, every hexagon has 4 times 180, or 720 degrees. Now you said an N-gon can always be divided into n-2 triangles. So what's the sum of the angles in an N-gon? Precisely. So if a polygon has n sides, then the sum of its angles is n-2 times 180 degrees. Let's take this formula for a spin and try it out on a sample problem. First, let's say what regular polygons are. A polygon is regular when all the angles are equal and all the sides have equal length. So here's a decagon, which is a polygon with 10 sides. And this is also a regular decagon because all the sides have equal length and all of these angles have the same measure. So what's the measure of one of these angles, like this one over here? You'll need this formula to figure it out, and if you get stuck, click down here. Nicely done! Each angle in a regular decagon is 144 degrees. And in any regular polygon with n sides, the measure of each angle is the sum of all the angles, which is n-2 times 180 degrees, divided by the total number of sides, which is n. Recall that a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So this is an example of a parallelogram because these two sides are parallel and these two sides are also parallel. Take a look at these three quadrilaterals down here. Which of these is a parallelogram? To review parallelograms and other kinds of quadrilaterals, click down here instead. Right, this is a parallelogram. Both pairs of opposite sides are parallel. Now there's another interesting feature about parallelograms we'll cover in this lesson. Take a look at this red angle down here. Which other angle in this parallelogram appears to be congruent to this angle? That is, which other angle appears to have the same measure? And to review measuring angles instead, click down here. Precisely. These two angles on opposite ends of the parallelogram seem to be congruent. Let's see if we can prove this is true using what you know about parallel lines. First, let's extend the four sides of the parallelogram into lines. So these two lines are still parallel, and these two lines are also parallel. Let's say this red angle has measure theta. For this angle, it looks like theta is about 60 degrees, but for now we'll just represent the measure as the Greek letter theta. Now these intersecting lines form a few other angles, but which angle is an alternate interior angle with the red one down here? There are actually two correct answers here, and if you're not sure, click down here to review alternate interior angles. Nicely done. So these two angles are alternate interior angles, which also means they're congruent. So this angle also has measure theta. Now of the four angles over here, which is corresponding to the angle over here? Excellent. This is the corresponding angle because you can move this angle so it lies perfectly on top. Corresponding angles are also congruent to each other, so this angle also has measure theta. So at this point, you've proven that these opposite angles in the parallelogram have the same measure. Next, let's take a look at the other two angles. Notice that this green angle over here is supplementary to this angle with measure theta. So in terms of theta, what's the measure of this green angle? Right, so this angle measures 180 degrees minus theta. And notice that this green angle is corresponding, and this angle makes an alternate interior pair with this one. So that means that this angle also measures 180 minus theta. And so we've proven that both pairs of opposite angles in parallelograms are always congruent. This pair is congruent, and this pair is also congruent. At this point, you can make your own parallelogram by dragging these yellow dots. The opposite angles are colored green and blue, and sure enough, it looks like the opposite pairs are congruent. Go ahead and make sure this is always true. Okay, so let's apply what you've discovered to this parallelogram here. Suppose this angle down here measures 70 degrees. Try finding the measures of the three remaining angles, and if you get stuck, click down here. Excellent work! There were a few different ways you could have solved this. First you found the opposite angle must also be 70 degrees, and that means the other two angles are each 110 degrees. So once again, you've proven that opposite angles in parallelograms are always congruent. And starting with just one angle in a parallelogram, you can use this fact to find all the other angles.